Check one, check two. I think we're recording. Audio's live. Here we go. Hello, welcome, and thank you for watching from wherever you are in the world. My name is Alexander Booth. Hello. I am the head program instructor, head facilitator, the head instructor for the IBM Data Science 10-week bootcamp starting April 2026. And this is your week 5 recap and week 6 preview. So, where do we come from? Where are we going here? Well, we just wrapped up week 5, which was our EDA week, is what I like to call it. But it's so much more than just a deep dive into exploratory data analysis. We start off on the left with the data wrangling. How do we clean up our data? Deep dive into pandas, making everything useful for statistical analysis. Dive into EDA, look at correlations, look at patterns and visualizations, distributions of the data sets, trying to understand if there's signal versus noise and what we can use to essentially make a decision on, right, in our downstream analytics. And then we end the week doing a preview of predictive modeling and machine learning. So the whole end of the week, we look at kind of regression analysis and building our line of best fit, understanding model training, model performance, as well as how to interpret and evaluate model metrics. And that's all week 5. Crazy week, really busy week. Again, going from data wrangling to exploratory data analysis to building your first models. So I have a breakdown of kind of what we did in lecture in week 5. If you haven't watched the recording, it is available on Zoom if you're in the session, or available on my YouTube as a backup, or if you're just following along with my YouTube content. So as I mentioned, this is a big lecture that ties together a lot of core ideas and is a good foundation setting for where we'll be in week 7 and 8 when we do a deep dive into machine learning. Big themes from lecture. Again, we're transitioning away from just looking at data infrastructure and coding best practices and coding patterns and actually moving into data science workflows. We go from extracting data, cleaning and preparing it specifically for analysis, exploration with our exploratory data analysis, modeling predictive algorithms, and then evaluating those model performances. Again, one thing just to hound though, data science really isn't just building predictive models. You do have to spend all of that work and effort up front to create a good data foundation by pre-processing and feature engineering new columns that have stronger signal than perhaps what is already currently in the data set. So first, a real quick breakdown of week 4. We went from why databases exist to how they are utilized as a single source of truth on many cloud and on-premise systems. We discussed the history, going from relational databases to open sources, to NoSQL databases in the 2000s, to cloud warehouses and data lakes in the 2010s, to lakehouse architectures in the 2020s. So I guess these do line up pretty well with decades. Relational databases was like your 70s and 80s, open source in the 90s, NoSQL in the 2000s, cloud in the 2010s, and lakehouses in the 2020s. We also briefly discussed modern interoperability and zero copy data sharing, which is an important concept in modern data platforms. This is your Iceberg, your Delta Share, your zero copy data lakes, which again, just to show this a thing. I got Salesforce here talking about their zero copy partner network and how do we move data across databases without having to format or move or anything. And Workday has something like this as well now, so I can find it. Workday Data Cloud. Yeah, here you go. The two-way zero copy. I'll have to find where it says zero copy here. There you go. There's multiple times. New buzzword alerts for 2026, zero copy approaches to interacting with data across a data cloud. So again, that's kind of where modern lakehouses has evolved into. So definitely read up on some of this stuff if you're curious about it. I think it is really interesting. Then we did our deep dive into week 5. So assuming you do have data, maybe it is from a zero copy data vendor, maybe it is from a data lakehouse or a relational database system. We need to inspect it and prepare it for data analysis. How do we prepare it for data science specifically? To do that, the first thing that I recommend doing when inspecting a data frame is to look for missing values. So your null values, are we missing data in our rows and our columns? Our data types, are we correctly formatted in terms of numeric, datetime, and string-based formatting? And then just fixing up the column names to make it easier for Python and pandas to select, manipulate, and interact with them. So we usually start out with df.info, and then from there going off and fixing our data. One thing we really harped on was missing data specifically. Obviously, with missing data, you have a couple of options. You can either drop it or impute it. That means to fill in or replace the missing values. We talked through the pros and cons of both, as well as when to use imputation for mean, median, as well as mode or categorical based imputations. Let's see. Then we dove into the second half, which is great. Now that you have all these columns, how do we engineer them for analysis? This could be creating new variables. It could be transforming existing variables or even normalizing variables. So some common ones we did was we transformed different columns into a standardized, I think in this case it was just the imperial units with pounds and inches. We also talked about how we could extract the month from a date time column and how the month could be a new feature, how we could add multiple features together to create like a total cost or a total area of the house or something like that. Data normalization, this is where we want to make sure that our numeric features are scaled consistently, especially for linear models that could identify patterns if there's outliers in the skew in the distribution. We want everything to be between 0 and 1, -5 to 5. We don't want to have some columns that go 1 to 10 and other columns that go 1 to a million, as those different ranges can cause noise within our modeling signal. Let's see here. Yep, by doing normalization, this reduces variance and helps your models detect patterns effectively. Again, mostly for linear-based models. When we talk into some more advanced machine learning weeks, if we talk about tree-based models, they are less prone to noise coming from that increased variance. And then finally, going back and forth with numeric data. Obviously, machine learning models, algorithms, linear models, even just averages, they need a number. It's really hard to do statistics on categories or strings. So how do we go from categories to numbers by using one-hot encoding or other types of encoding methods, right? So we'll talk about that a little bit further here up at the top. Another one, though, is before you even do that, maybe going from numeric to categorical and then to your categorical features. So a common example for this is age. Let's go from age to an age group. So we bin into 4 categories or 5 categories, whatever, and then we one-hot encode off of those categories. And that can actually create more signal than just having the raw age itself. So once we've done all of this pre-processing, feature engineering, we really have a strong understanding of our data. It's time to look for relationships between our data sets. So this is what I talked about earlier with correlation analysis. We can look for correlations between our numeric features. We can look at the different distributions to identify skew or to discover patterns. Basically, this is the big purpose of EDA. How do we find signal and patterns that mean something in our data sets? And also, that could also mean that this is a bad column to use for modeling. So sometimes the explorations can help us find weak patterns or weak features in our data sets. Go sneak preview week 6, where we're going this week, is all going to be focused on data visualization. Part of that will be EDA, looking at distribution-based analysis, but it'll also be covered more in depth with dashboard design and things like that too. Finally, when we think we do have a solid set of features and a target, we can move into linear modeling. So in this week, we introduce linear regression, essentially your line of best fit, typically modeled as y equals mx plus b, or if you have multiple features, y equals m1 x1 plus m2 x2 plus m3 x3. And then from there, we also, I think, talked about polynomial regression as well. We can add in squared values, x1, x squared, or x cubed, things like that. And that polynomial regression can also help us identify really strong nonlinear patterns in the data set as well. Why we start with linear models? Linear models have been around for a very long time. They're very explainable. They're defensible in mathematics as they're all rooted in mathematical proofs. And because people were doing them with quills and pens and paper. They're very easy and straightforward for computers to do as well. So we like to call that computationally efficient. Your laptop is not going to be running for a week training a linear model. It should be done within a matter of seconds. Let's see here. Once we have a model, we need to figure out if it's good or not. We typically talk about this with the concept of model evaluation, where we look at metrics. We spend a lot of time in lecture talking about R squared as well as your mean squared error, but it's also good to learn about other ones such as MAE, your mean absolute error, as well as your root mean squared error. We'll dive into more of those metrics later on in our machine learning weeks coming up here. Same thing with the idea of train test split and overfitting. These are more advanced machine learning concepts that we just talked about at a high level. Essentially, that we want to train our data. We want to evaluate our models on data that the model hasn't seen yet, so it's representative of the real world. That's why we withhold some of that data for model evaluation or the testing for a phase. Overfitting occurs when a model learns noise in its data set, right? So if it's really bad at predicting models in the real or predicting data in the real world, that typically means your model is overfit on the training set. And again, this is why it's important to have a good EDA, to have good pattern recognition. If the model is overfit, then you think it's going to do well when in reality it doesn't. And that could be due to skew in the data, that disparate ranges, right? Maybe poor model, poor data encoding, things like that as well. Biggest idea from all of week 5, garbage in, garbage out. If you have garbage data, you'll have a garbage model. We need to be really clear with how we approach data pre-processing. Honestly, clean data and good features and a strong understanding of the patterns and signal in the data is more important than any of the downstream models itself, right? Even when we talk in weeks 7 and 8 about using more advanced machine learning models like neural networks and XGBoost and all that good stuff, if you still have bad data, better algorithms won't be a band-aid for bad data. Where we're going next, like I said, we'll do our quick preview of week 6 here in a sec. We're going to be doing more advanced visualization, dashboarding, business intelligence topics, as well as doing some more discussions around EDA. Then we'll move into machine learning for a couple of weeks, and then we'll do our capstone project. So it should be a good time. I don't think it's worth clicking on any of these links. A couple things I want to call out in the forum. Karen had a really good post about the different ways of categorical encoding. Again, this is a really important concept as training a model requires it to be in a numerical format. So knowing the different ways that we can encode our strings is important, right? So we talked about one-hot encoding already. That creates a new column for each category, basically having a 1 or a 0 for each option. But another one that's important to call out is something around like nominal encoding. So we actually do this all the time. If you think about it, the month of the year, January to December, those are categories. January, February, March, April, those are strings that are being used as a category. However, we represent those categories with increasing numbers, 1 for January, 6 for June, and 12 for December. But that could introduce a pattern, right? This is the problem with nominal encoding. A model could see that December is 12 times better than January just because of those ranges, right? It's an implied pattern when you're increasing the values. So again, we'd probably recommend one-hot encoding for many solutions here because it removes a lot of that variance. But again, knowing the breakdown of all of these is super important. So thanks to Karen for sharing that. Let's see. In lecture itself, obviously everything from lecture and my lecture notes and all the live session material is all up in GitLab. I want to make sure I didn't miss anything too much on the week. Let me check. I think all we did was we talked a little bit about data wrangling and then did basically our final project. So it's the housing sales in King County. Pretty interesting problem set. Bringing in our data, do our .info. We notice that we have bad data. We have missing values. The column names are fine. So then we end up doing some data cleaning, dropping some unneeded columns, looking at the distributions of various data sets here, Notice that we took the mode of bedrooms and then used that to impute our missing values. So imputations with mean and mode. We fixed our date time. We actually cast it to the correct date type. And then from there, we're able to feature engineer out a new column called month. Do our EDA, look for distributions. Again, this is grouped, the distribution of price grouped by whether or not the property is on a waterfront. Talked about looking at the shape of data, the shape of view, looking at different correlation metrics here. Definitely a strong correlation between the size of the house and the price of the house. From there, we build out a few models. We do a regular linear regression. Then we build out a polynomial regression, which adds in, like I said, that like x squared features. And then when we compare the performance, we should see that a polynomial, I think polynomial ridge performed the best, right? 7.5 or 7.11 on the training on the test set. So this was a ridge regression, which tries to remove some of the multicollinearity that can plague traditional linear regression models. Yeah, we'll see that we went from a 647 r squared to a 712 r squared just by adding in a scalar and a polynomial feature. So then that's that normalization as well as the x squared components. So pretty cool notebook. Again, take your time with this one. It's a pretty strong foundation for where we're going in the next few weeks. I think we did it in about half an hour, but if you take up to an hour on it, don't be surprised. All right, let's pivot here into our week 6 preview, just so we can finish knocking this out. Week 6 preview, obviously all the week 6 content I've already run this week and backed up into my GitHub. I also added in a preview forum post a couple of days ago. So we'll go over that. We'll go over a couple of things to call out with Dash and the code, and then we'll do this a quick wrap. So yeah, week six is all about data visualization. We're going to be creating data visualization for reporting tools, for interactive business intelligence, as well as for our own exploratory analysis of underlying feature sets. So a lot of good use cases for data viz. So you to repeat those. Use cases for data visualizations include individual exploratory analysis of data distributions, of correlations, of patterns like that for your own understanding of the data set. 2, creating visualizations for static reports. So we did this a little bit earlier in the bootcamp. We created those bar charts and line charts using matplotlib. Great, save them off, embed them in a slide deck, call it a day. And then 2, or the third last one, we're going to be creating visualizations for interactive business intelligence. So this will be your interactive self-serve data analytics via dashboards. In our case here, we will be using the open source interactive dashboarding tool called Dash, but this could easily be translated into your Tableau, Power BI, Lookers of the world. So we're going to move from analyzing data to communicating those insights visually. How do we visualize patterns, trends, relationships, and outliers? How do we use different chart types? Just listing a few here: line, bar, histogram, area, bubble. How do we use colors? How do we use interactivity for actually building these really self-serve dashboards? We'll also be creating maps and using Seaborn. I think both of those shouldn't be too new here to us. Let's see, by the end of where we're going, we'll be moving from loading data into a table to building your static visual insights for your own analysis and static visualizations to moving to creative interactive visualizations with Folium, Plotly, and Dash. So it's a pretty busy week, but again, take your time with it. Don't feel like you have to get every notebook done 100%. I don't think it's that many notebooks. I think it's about 10 notebooks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 notebooks. So again, it's a bit intense, but again, the first half will all be on static visualizations. The second half will all be on interactive Dash applications. So just like always, spend the time where you need it, whether it's on new visualization topics or dashboards. Right. I had a lot of fun creating the maps, then the waffle charts and the natural language like word clouds and stuff. So 610, 611, 612 are probably the most important ones to me, or 613, I guess. So yeah, creating advanced visualizations, creating an interactive visualizations, and then creating dashboards. But definitely spend more time on the first half of lectures too, if you wanted that extra experience with Matplotlib and Seaborn. Let's see here. Always use my notebooks as a source of truth, and feel free to paste or share any visualizations you make in the week in the lounge or any of the discussion forums. Would love to see them. All right, a couple call outs on the Dash apps. Sometimes on the media sets for the Dash apps, it'll give you a comment to copy over into the IDE that says Python 3.8. Don't use Python 3.8. We're going to be using regular, just Python 3 for that, right? So I think I did see this in a couple of the last options here. Let's see if I can find an example of this real quick. Do, do, do. So I'm in 612, which is kind of where we start doing. Oh, there we go. Plotly basics. No, that's the notebook. Do dash basics. Here we go. So let me pull up this this first option. Oh, this cheat sheet's pretty good too. You know what? I'm gonna download this real quick. So you see me doing this live on my recording. Cool. Anyway, I wanted to show in the lab. Oh, it still hasn't loaded yet. It's kind of what I'm talking about with that Python 3.8 stuff. Oh yeah, and then Karen's got a good. All right, I think that's clicking over. All right, so here we go. So this is kind of what we're talking about with the kind of IDE labs here. So again, it's a full lab that we have to do for Dash. And as you start clicking through, it's going to teach us how to even start doing things. First thing we need to do, get our tools ready. And that's kind of what I was talking about, right? This is Python 3.8 and then install packaging. Technically, I think this will work, but it's just not correct. And I have seen it with some of the downstream options that basically switch between the Python versions. So yeah, actually, let me just show you this. If I go, let me get rid of all that. So in my terminal, if I just do Python 3 dash dash version, it says I'm running 3.10, right? Python 3.10. So I shouldn't be running Python 3.8 for this. So anyway, what we're going to do here is we'll copy these over, but we should replace the 3.8 with just 3. So it'll look like this. Python 3-m pip install packaging. And that'll correctly install the right version of the library. Same thing with the next one. So this should also just say Python 3. So that's going to install pandas and dash. Pip 3 is fine, so this one should work fine if I copy this over. And then I'll show you how we'll run this dash notebook here. So that works. Let's do this last install. Sweet. And then what it's asking us to do in the user interface here, again, this is that Visual Studio Code ripoff, or I guess fork. So we're going to click on the two pieces of paper here at the top, and then we're going to click on this first icon to make a new piece of paper, and we're going to call it dash basics.py. Cool. And then if you just skip to kind of the end of the activity, it should give us like the full thing. So again, obviously read all this and pay attention to it, but for the sake of example, I'm skipping through it. So here we go. Reference the entire Python code block here, copy this, shove it into our file, save it. And now again, I recommend adding the debug equals true. If you add the debug equals true here, this will also allow you to update the dashboard in real time, and you don't have to like save and redeploy and stuff. So all I've added, I posted this in, added that debug equals true thing, and you'll see that to run the application, we just need to call Python 3, not 3.8, and then the name of the file, dash basics.py. That should run the file, and we should be able to, what do we say? Launch your application. How do we do that? Down here. Oh, yeah, here, launch application. Application port number is going to be 8050. And then let's open this in a new tab. Magic. Look at that. We have a beautiful little dashboard and Python thing. And it's all interactive. I can click on stuff and things change. So pretty cool. And again, just to show why I like doing the debug equals true. If I change the title, so I can let me grab the with this H1 title that says airline dashboard. If I just add this and say like booths airline dashboard, save it. It should automatically just work. Again, I kind of broke the syntax there, but it should automatically just work. And then if I refresh my web page, there you go. It automatically says Booth's airline dashboard. So pretty cool that things automatically update for you. Again, to me, the Dash applications are the ones that are the most complicated part of the project this week. So definitely spend the most time on those and just make sure you understand how to run them correctly, as well as using the right like Python syntax. Lots other thing to call out here. The syntax for writing Dash and Plotly applications are pretty different than what we're used to. So Karen has a great deep dive into event-driven architecture, where we want to write our program so that it listens for events and then responds to those events. So that's essentially what a callback function is. Whether a user clicks on something or some automation happens, we are responding to events happening in the application around us, as opposed to just going top to bottom and creating a single application layer. So a lot of good stuff around the user interface, the front end, the back end, the database, and all of these different versions of languages that make websites work. So good post from Karen there as well. To finish this up in my preview for week 6, again, all my lecture notes and everything is already in GitHub for this week. Nothing too crazy. Again, you can read my big ideas here. How do we use visualizations, turning data into understanding, all that good stuff. We'll walk through all of that in class. And then you'll see, yeah, what we're doing is creating these different data visualizations, understanding how to format everything, go from visualizing with pandas and matplotlib to moving into Seaborn and distribution plots and specialized plots, and then into the fun advanced visualizations with kind of your waffle charts, word clouds, Folium maps, Plotly, and Dash dashboarding. So yeah, just like any other week, as the week builds, and to me, the most important content is at the end of the week. So definitely focus your time there. We're building your visualization toolkit. We're not just creating just one-off charts. The goal is to understand the right plot, the right plotting library, and the right requirements for your visualizations, whether it's interactivity, static reports, slide decks, right? Self-serve data exploration for your stakeholders. How do you use all the tools available to us as a data scientist to tell stories with trusted conclusions, from static plots to maps to your live dashboards? So, pretty fun week. Looking forward to seeing what everybody builds this week. Quick reminder, we do have our normal lecture as normal on Monday. So I will see everybody in a couple of days during our lecture. Thanks for the time. Please reach out on the forums if you need us. Would love to kind of get some discussions going on here with what Karen and I are talking about, as well as with the general forum post for this week, which is mostly how do we talk about Tufty? How do we talk about a good use case of space in our dashboard? How do you like respond to graphic design principles, right? How do you not lie with your data sets? So definitely some really interesting discussions here. This is an area that I'm passionate about. There's a really fun subreddit called Data is Ugly, which is all full of really ugly visualizations. So again, like, how do you know why these are bad, and how do you know that how do you make them better, right? Like, how do you declutter all of this, or how do you use the space available in your graph for the right content? Like, God, there's some really gross looking visualizations. So. Anyway, I appreciate the time spending that you spent watching this video, and I will see everybody in our next lecture on Monday, where we'll do a deep dive into data visualization topics. Thanks, everybody. Enjoy the weekend, and I'll see you in a few days. Alexander out.